Welcome, my friends. You might remember that a polynomial is a term, or the sum of two or more terms, whose variables have whole number exponents. For example, y equals 3x squared plus 7x plus 4 is a function that is a polynomial. Things like square roots, logs, or exponential functions are not allowed in polynomials. A rational function is a function involving the ratio of two polynomials. An example of a rational function is y equals 3x squared plus 7x plus 4 divided by 2x plus 3. Both the numerator and denominator are polynomials, which is what makes this a rational function. A nice fact about polynomial functions is that the domain, the possible values for x, will always be all real numbers. There is no restriction on what values for x can be plugged into any polynomial. That's not the case with rational functions. They typically have a restricted domain due to the possibility of their denominator equaling 0. We know that division by 0 is undefined in mathematics, so the domain of a rational function is all numbers where the denominator is not equal to 0. For example, in 3x squared plus 7x plus 4 divided by 2x plus 3, the domain would be restricted to all values where the denominator of 2x plus 3 is not equal to 0. To find out where that is, we set 2x plus 3 equal to 0 and solve for x. Subtracting 3 from both sides, we have 2x is equal to negative 3. Dividing by 2, we have x is equal to negative 3 halves. The domain of this rational function includes all numbers except x equals negative 3 halves. Sometimes we need to factor the denominator to determine where the denominator is equal to 0. Take, for example, f of x is equal to x squared minus 2x minus 24 divided by x squared minus 4x plus 3, which we want to find the domain of. We don't really care about the numerator. All we care is that the denominator is not equal to 0, so we set x squared minus 4x plus 3 equal to 0. The best way to solve this, since we have both an x and an x squared term, is to factor. We need to find two numbers that add to our b value of negative 4 and multiply to our c value of positive 3. Negative 3 and negative 1 should do it, as negative 3 times negative 1 is equal to positive 3, and negative 3 plus negative 1 is equal to negative 4. We have x minus 3 times x minus 1 is equal to 0. Now, you might be familiar with the zero product property, which says that the only way the product of two numbers can equal 0 is if at least one of the two numbers alone is equal to 0. Written out, the zero product property says that if a times b is equal to 0, then either a or b is equal to 0. In this case, we have x minus 3 times x minus 1 all set to 0. The only way this can be true is if either x minus 3 or x minus 1 is equal to 0. If x minus 3 is equal to 0, then that must mean that x is equal to 3. If x minus 1 is equal to 0, then that must mean that x is equal to positive 1. Therefore, the two values for which our function is undefined and which are excluded from the domain are x equals 3 and x is equal to 1. Let's try one more. We want to find all excluded values from the expression y squared plus 3y minus 54 divided by y squared minus 25. This is basically the same thing as asking which values are not in the domain of the function. This is a rational function, which means it is undefined where the denominator of y squared minus 25 is equal to 0. You may recognize this as the difference of squares, which can be factored as y plus 5 times y minus 5. By the zero product property, that means that either y plus 5 is equal to 0 or y minus 5 is equal to 0. We have y equals negative 5 from the first equation or y equals 5 from the second equation. The values y equals negative 5 and y equals positive 5 make the denominator 0 and therefore are excluded from this expression. Alright, my friends, that completes our discussion of the domain of rational functions.